The Newton-Raphson method. The Newton-Raphson method for system of first Newton-Raphson method for two variables only. So Newton-Raphson method, by solving the system of nonlinear equations, phi of x comma y is equals to 0, psi of x comma y is equals to 0. X naught comma y naught. So x naught comma y naught is 0th iterative value. So we have to find out first iteration, second iteration, third iteration. Up to any two iterations are nearly equal. So phi of x naught plus h comma y naught minus k is equals to 0. First, the psi of x naught plus h comma y naught plus k is equals to 0. Differentiate with respect to x and y. So differentiate with respect to x and y. So we are getting dou pi by dou x, like this. Dou pi by dou x, dou pi by dou y, dou psi by dou x, dou psi by dou y. So these are the first. So these are the first order derivatives of pi and psi with respect to x and y. You know? So these are the first order derivatives. And so these are the formulas for h and k. H formula, k formula. H is equals to minus pi of x naught comma y naught and pi of x naught comma y naught minus psi comma pi of x naught comma y naught. So minus of pi x naught comma y naught pi of x naught comma y naught sin psi y.
Why is it not clear, sir?
Pi x. These are h and k formulas. So k is equals to pi x pi psi y divided by pi x pi by psi x psi y. So these are the h. వాయిస్ రావట్లేదా?
వీడియో
వీడియో ఇప్పుడు వస్తుందండి.
సార్ ఐగన్ వెక్టర్స్ చెప్తున్నారు కదా సార్.
ఏంటన్నా
ఐగన్ వెక్టర్స్ చెప్తారన్నారు కదా సార్.
లాస్ట్ క్లాస్ లో సిస్టమ్ ఆఫ్ హోమోజీనియస్ లీనియర్ ఈక్వేషన్ చెప్పాను. సిస్టమ్ ఆఫ్ నాన్ కంప్లీట్ అయిపోయిన తర్వాత
సార్ వాయిస్ కూడా క్లియర్ గా లేదు సార్.
వాయిస్ రావట్లేదా?
ఇప్పుడు వచ్చింది.
మన వాయిస్ మీకు ఎవరికైనా క్లియర్ గా ఉందా? వీడియో
ఓకే సార్.
సార్
so these are the H and K formulas. Next steps to solving Newton-Raphson method. First step, so is given two equations. So first equation is phi of x comma y is equals to 0. Second equation is psi of x comma y is equals to 0. And also is given zeroth iterative values. So zeroth iterative values x of 0, y of 0. And in second step, using phi of x comma y, psi of x comma y is nothing but, so differentiate phi comma psi with respect to x and y. So differentiate pi comma psi with respect to x and y. So next step. Third step. So we have to find h comma k values. H comma k. In equation number 4 and 5 is nothing but find out h comma k. This is step 3. Next step 4. Next we have to find out first iterative values x1, y1. First iterative values. So next repeat the process. Second iterative value, third iterative, fourth iterative. So continue this process up to any two iterations are nearly equal. So second iterative value, how to find out first or second iterative values. So this is second iterative value formula. X2 is equals to x1 plus h2. Y2 is equals to y1 plus k2. So first iterative is nothing but x1 is equals to x0 plus h1. X1 is equals to x0, y0, y1 is equals to y0 plus k1. So these are the iterative values. So continue this process until any two successive approximations are nearly equal. Is clear? So this is the process to find out the solution of system of equations in Newton-Raphson method. So for example, example 1 is given two equations in Newton-Raphson method, and also is given two equations, and zeroth iteration values is nothing but, so these are the zeroth iterative values 3.4 comma 2.2. So these are the zeroth iterative values. So these two curves intersecting on a graph. So intersecting point is 3.4 comma 2.2. So this is the zeroth iterative value, or otherwise, so we can take x0 is equals to 0 and y0 is equals to 0. So in this case, we are getting number of iterations. Like so directly we can take 3.4 comma 2.4. We are getting the solution only 2 or 3 steps. So but we can take x0 is equal 0, y0 is equal 0, increasing the iterations like 9th iteration or 10th iteration. So but answer is same. So these are the x0 and y0. X0, y0 is equal to 0.4 comma 2.2. So these are the zeroth iterative values, and is given two equations. So this is first equation. So this is second equation. So first equation is phi of x comma y. So pi of x comma y is equals to x plus 3 log base 10 x minus y squared. So this is pi of x. So second equation, psi of x comma y is equals to 2x square minus x minus 5x plus 1. So these are the pi and psi. So first step is nothing but, so assume given equations phi of x comma y and psi of x comma y, and also identify x naught and y naught is nothing but zeroth iterative values. So that is, then pi of x naught comma y naught is equal to, substitute x naught and y naught on equation 1 and also equation 2. So 0.1544. The psi of x naught comma y naught, so minus 0.72. So these are the pi comma psi at zeroth iterative values. Pi comma psi are the zeroth iterative values are 0.15 minus 0.72. So next, second step. The second step is nothing but, so differentiate pi comma psi with respect to x and y. So differentiate pi comma psi with respect to x and y. So differentiation of x1, this one, with respect to x, differentiation of x1. So 3 is constant. So log x differentiation 1 by x. Log x differentiation 1 by x. So here y square differentiation is 0, because here we are doing differentiation with respect to x. Y is constant 0. At x is equals to 0, at x naught is equals to 3.4. So 1 plus 3 by 4, 0. Log base e, 0.43. So this is the dou pi by dou x at x naught. Similarly, dou pi by dou y. So differentiate with respect to y. So next, pi differentiation with respect to y. So x is constant, x constant 0. So 3 log x also constant 0. So y square differentiation minus 2y. So minus is there. Y square differentiation 2y. Next, psi differentiation with respect to x and y. With respect to x, 4x. X square differentiation 2x, already 2 is there, 4x minus y is constant, x differentiation 1 minus y. So minus 5x, x differentiation 1, y is constant, plus 1 differentiation 0. So next, psi differentiation with respect to y. So here x square is there, first term 0, x is constant, total term 0. So next, 1 also constant, 0, 5x also constant. So these all are, 3 terms are constant, 0. So only x into y term is there. With respect to differentiation y, x is constant, minus x. Y differentiation 1. So that is minus x. So these are the differentiations pi comma psi with respect to x and y. So these are. First is given 2 equations, that is pi comma psi. Next, differentiate pi comma psi with respect to x and y. So these are the first order derivatives of pi and psi. So next, the substitute x naught comma y naught values in place of x naught, in place of y naught. That is 0th iterative values. So pi, dou pi by dou x at x naught comma y naught. So 0th iterative value 1.388. So here, in these first order derivatives, So substitute x is equals to x naught, y is equals to y naught. So we are getting first order derivatives at 0th iteration. So dou pi by dou x, x naught comma y naught is equals to 1.383. Next, dou pi by dou y, x naught comma y naught is equals to 4.4. Second one here. So next, dou pi by dou x, dou psi by dou x is equals to 4x naught minus y naught minus 5. So that is 6.4. Next, dou pi by dou psi by dou y. So that is equals to minus x. So minus 3.4. After differentiation with respect to x and y, so substitute x naught and y naught values. Next. So substituting these values in equation 4 and 5. Equation 4 and 5, find that h1 comma k1, h1 comma k1 values. So h1 comma k1 using these equations. h1. So this is h1 k1 formulas. Zeroth order derivatives. h1 comma k1 values. So substitute in these two formulas. So we are getting h1 and k1. So that is h1 is equals to 0.157, k1 is equals to 0.085. So these are the h1 k. So next, x1 is equals to x naught plus h1. So these are the first order derivatives. So first order derivatives, x1 minus x0 is equals to h. Length of the interval, x1 minus x0 is equals to h. So similarly, y1 minus y0 is equals to k. So these are the length of the interval, x1 minus x0 is equals to h. Similarly, x2 minus x1 is equals to h. y2 minus y1 is equals to k. So length of the interval is same. Here also, x1 minus x0 is equals to plus h. Here also, y1 minus y0 plus k1. So here h1, x1. So these are the x1, y1. x1 is equals to x0 plus h. y1 is equals to y0 plus k. So these are the two formulas. Here different is there. So 2.285, 3.357. So this is first iteration of x1. So this is the first iteration of y1. So substituting x1, y1 in pi of x and psi of x comma y. So that is pi of x1 comma y1, psi of x1 comma y1. So that is, so these are the pi comma psi values in first iteration. Pi comma psi values in first iteration. Pi of x1 comma y1 is equals to minus 0.011. Psi of x1 comma y1 is equals to 0.3945. So these are the first iterative values. So next. So next. So these are the derivatives. I comma I derivatives. X with respect to x with respect to y. So in previous, so substitute x is equals to x1, y is equals to y1 in these equations. Here. In these equations, so substitute x is equals to x1, y is equals to y1. So we are getting dou pi by dou x at x1 comma y1, dou pi by dou y at x1 comma y1, dou psi by dou x at x1 comma y1. So next, dou psi by dou y at x1 comma y1. That is first iterative values. So these are first iterative values. So dou pi by dou x x1 y1, dou pi by dou y x1 y1. So these are the first order derivatives at x1 comma y1. So next same, we have to calculate h2 comma k2, same formula using equation 4 and 5, previous formulas, h1 h2, next h2 k2, same formula. So this one, using these two, we have to find out h2 k2 values. So in place of x0 y0, so here we are taking x1 comma y1. h2 comma k2, same process. x2 is equals to second iterative is equals to x1 plus h2, y is equals to y1 plus k2. So similarly here also x1 is equals to x0 plus x2 y2. Similarly, so we can find x3 and y3 also. x3 x3 and y3. x2. Second iteration is equals to first iteration plus h2. So y2, first iteration plus k2, that is 3.4885 plus 2.261. So these are the second iterative values of x comma y. So next, so substituting x2 y2 for x and y in pi and psi. So that is, so we have to calculate pi comma psi values at second iterative. So that is pi of x2 comma y2 and psi of x2 comma y2. So we have to find out pi of x2 comma y2 and psi of x2 comma y2 and also h3 comma k3 values. So at this point x3 and y3, so these are nearly equal. Continue this process up to any two iterations are nearly equal, up to two or three decimal places. So second iteration of x2, so 3.48. So third iteration of x2, 3.47. Here y2, 2.26, 2.26. So this is the solution for given system of equations. So this is the two variables only. So Newton-Raphson method for three equations and three unknowns. So previous example is nothing but only x and y, only two variables. So but here x, y and z also three variables. Here also same process. So but here three equations. So first one pi, psi and gamma. Same. So differentiate. So three equations, pi is equal to 0, psi is equals to 0, gamma is equal to 0, equation 6. So the x naught comma, y naught comma, z naught are the zeroth iteration values. X naught, y naught, z naught are initial approximation values are zeroth iteration values. And h comma k comma l, h comma k comma l corrections to the approximate values. So these are the h, k, l. H comma k comma l are the corrections of the approximate values. So that is x is equals to x naught plus h, y is equals to y naught plus k, z is equals to z naught plus l. X is equals to x naught plus h, y is equals to y naught plus k, z is equals to z naught plus l. So that is pi of x naught plus h comma y naught plus k comma z naught plus l is equals to 0. Next, psi of x naught plus h comma y naught plus k comma z naught plus l is equal to 0. So these are pi, psi, gamma or zeroth iteration values. Pi, psi, gamma. Expanding equation 7. So this is equation 7. Expanding in equation 7 using Taylor's theorem. So expansion of this pi of x naught plus h comma y naught plus k comma z naught plus l in Taylor's theorem. Pi of x naught comma y naught comma z naught, zeroth iteration value plus h into first derivative of pi, dou pi by dou x at zeroth iteration values, plus k into dou pi by dou y with zeroth iteration values, plus L into dou pi by dou z at zeroth iteration values. So pi at zeroth iteration values and dou pi by dou x, first derivatives of pi with respect to x, y, z in zeroth iteration values. So this is the formula. Same formulas for psi also. In place of pi, so we can take psi of x naught comma y naught comma z naught plus h into, so dou psi by dou x, zeroth iteration values, plus k into dou psi by dou y at zeroth iteration, plus L into dou psi by dou z at zeroth iteration. Next, gamma also. So these are the three formulas by using Taylor's theorem. So Taylor's theorem expansion. Solving the above equations, so we are getting approximate solution of the given system of equations. Example, solve the system of equations x square plus y square plus z square is equals to 9 and x into y into z is equals to 1, x plus y minus z square is equals to 0. By using Newton-Raphson method, so he is given zeroth iteration values x naught, y naught, z naught. X naught is equals to 2.5, y naught is equals to 0.2, z naught is equals to 1.6. So these are the zeroth iteration values. So first equation is pi. So this is psi. So next, gamma. So pi, psi, gamma. So these are the given equations. So pi of x comma y comma z is equals to x square plus y square plus z square minus 9. Psi of x comma y comma z is equals to x into y into z minus 1. So next, gamma of x comma y comma z is equals to x plus y minus z square. So next we have to find out derivatives. Derivatives of equation 1. Derivatives of equation 1 with respect to three variables x, y, z. So differentiate equation 1 with respect to x, y, z. Okay. First step is nothing but given equations pi, psi, gamma. So next, differentiate equation 1 with respect to x, y, z. So differentiation of pi with respect to x. So with respect to x. So x square is there, x square differentiation 2x. Remaining three numbers are constants 0. Y square differentiation 2y. Z square differentiation 2z. Remaining all are zeros because we are doing differentiation with respect to x. We are treating y, z as constant. So differentiation with respect to y, x and z is constant. So differentiation with respect to z, x, y is constant. Next, so differentiation of psi with respect to x, y, z. So here 1 is constant, always 0. With respect to x is nothing but y, z. With respect to y is nothing but x, z. With respect to z is nothing but x, y. So these are the differentiation with respect to x, y, z of psi. So next, last one, differentiation with respect to x, y, z of gamma. So differentiation with respect to x is nothing but 1. X differentiation 1. Remaining all are constants 0. So next, gamma differentiation with respect to y is 1. Remaining all are zeros. So gamma differentiation with respect to z, 2z. Remaining all are zeros. So these are the pi, psi, gamma. And these are the derivatives. So derivatives of pi, psi, gamma with respect to x, y, z. So next we have to find out zeroth iteration values of pi, psi, gamma is nothing but substitute. So this is x naught, y naught, z naught in equation 1. So pi of 0. So pi of 0 is equals to pi of 0 is equal pi of 0 is equals to, so here x naught square plus y naught square plus z naught square minus 9. So pi psi of 0 is equals to x naught, y naught, z naught minus 1. So next, gamma of 0 is equals to x naught plus y naught minus z naught square. So these are the zeroth derivatives of zeroth approximation or iteration values of pi, psi, gamma. So minus 0.15, 0.20, 0.14. So next, derivatives. So next we have to find out derivatives at zeroth approximation, like x is equals to x naught, y is equals to y naught, z is equals to z naught, and in equation number 2. So this is equation 2. So substitute x is equals to x naught, y is equals to y naught, z is equals to z naught. So that is, so these are the dou pi by dou x at x naught, y naught, z naught, dou pi by dou y at zeroth iteration values, dou pi by dou z. So similarly, psi also. So these are pi. So next psi and gamma also at zeroth iteration or zeroth approximation derivatives. Hence, the equations to be solved. So here equations. So first one, 5 into, so dou pi by dou x, x naught, y naught, z naught. This value is 5. 5 into h1. 5 into h1 plus 0.4 into k1 plus 3.2 into L1. So next, 0.32 into H1 plus 4 into K1 plus 0.5 into L2 is equals to, so these values are RHS are 0. minus 0.15 minus 0.20, 0.14. So similarly, third equation also. Third equation here, 1 is there. 1 into H1 plus 1 into K1 minus 3.2 into L1. So 0.14. Solving these three equations, we are getting H1, K1, L1. H1, K1, L1. So these are the H1, K1, L1 values. So we have to find out first approximation. So first approximation, x1 is equals to x naught plus h1. y1 is equals to y naught plus k1. z1 is equals to z naught plus l1. So these are the first approximation values in Newton-Raphson method. If three variables are given, is asking only up to first order derivative. Perform only one iteration. So that is x1, y1, z1. That's all. Only one example is there in this method. Next, iteration method for solving simultaneous equations in 2 and 3 variables or 2 and 3 unknowns. Gauss-Seidel iteration method. So in Gauss-Seidel iteration method for 2 variables, suppose we have to solve the system of 2 nonlinear equations. First equation pi and second equation psi. In the iteration method, one has to express the given equation. Given equation is of the form x is equals to f1, y is equals to f2. So given system of equations can be expressed is of the form x is equals to f1, y is equals to f2. So suppose x naught comma y naught, x naught comma y naught are the zeroth or first approximation, zeroth or initial approximation solutions. So next, then the performing the successive iterations, you will get x1, y1, x2, y2. So for the first approximation, here, the formula, first approximation formula, in first approximation, we have to substitute zeroth approximation values in this equation. The next, second approximation, second approximation, we have to substitute first approximation values. So this is the iteration process. So next we have to find out the third approximation values. So substitute second approximation values on here. X3 is equals to F1 of X2 comma Y2. Y3 is equals to F2 of X3 comma Y3. So these are the third approximation values. So continue this process up to any two iterations are nearly equal, up to 3 decimal places or 2 decimal places. So this is the iteration process. Up to kth iteration. So kth iteration, x power k is equals to f1 of x power k minus 1 comma y power k minus 1. Y power k is equals to f2 of x power k minus 1 comma y power k minus 1. K is equals to 1, 2, 3. So this is the only for second, only 2 variables are given. Next, 3 variables. So Gauss-Seidel iteration method for 3 equations are 3 unknown values. So 3 system of equations, pi, psi, gamma. Pi is equal 0, psi is equal 0, gamma is equals to 0. So express the given system of equations is of the form x is equals to f1, y is equals to f2, z is equals to f3, x is equals to f1, y is equals to f2, z is equals to f3. And also x0, y0, z0. X0, y0, z0 are the initial approximation values are 0th approximation values. So next we have to find out first approximation values. So substitute 0th approximation values on here. Put x is equals to x0, y is equals to y0, z is equals to z0. X is equals to x0, y is equals to y0, z is equals to z0. So these are the 0th approximation values for x0, y0, z0. So this is the formula for first approximation. Next, second approximation. So second approximation, so substitute first approximation values in equation 1. We are getting second approximation. So similarly, kth approximation values. So kth approximation values, so substitute k minus 1 approximation values. So this is the Gauss-Seidel iteration method. Example. Example 3. So same 2 variables question. So this is pi, psi. Pi is equals to x plus 3 log x minus y square. Psi is equals to 2x square minus xy minus 5 plus 1. So this is Newton. This is only for 2 variables, x and y. So starting with initial approximation values, x0 is equals to 3.4, y0 is equals to 2.2. So starting, these are the initial approximation values indicated by the intersection of graphs. So drawing graphs of these 2 lines, intersecting point is x0 comma y0. The intersecting values is 3.4 comma 2.2. So these are the x0 comma y0 are 0th initial approximation values. So next, so x1, x is equals to f1 of x comma y is equals to f2 of x comma y. So express equation. So these 2 equations in x comma y. Express pi comma psi values in x comma y. So here x is equals to. So in this equation, x is equals to y square minus 3 log x. X is equals to y square minus 3 log x. In second equation, y value. In second equation, y is equals to 1 by x plus 2x minus 5. 1 by x plus 2x minus y. So these are the x comma y values. So next, we have to find out first iteration, x1. X1 is equals to substitute 0th iteration values on here. 0th iteration values. Y0 whole square minus 3 log x0. minus 3 log x naught. So this is x1. So this is x1 value. So next we have to find out y1 value. Y1 value to substitute 0th iteration values are x. Substitute previous values, that is x1 is equals to 1 by x1 plus 2x1. So we have to find out y first iteration by using x first iteration value. In case we don't know x first iteration value, so we can take 0th iteration of our initial approximation of x. So here we know the value of first approximation of x1. So that is y1 is equals to 1 by x1 plus 2x1 minus 5. So this is y1. So similarly, y2, x2, x2. Using first approximation, y1 square minus 3 log x1. Next, x2. x2 is equals to, we are using x2. Y2 is equals to, we are using x2 values. 1 by second approximation of x2 plus 2 into second approximation of x2 minus 5. So this is the second approximation of y. Next, 3, 4. Third approximation and fourth approximation. So continue this process up to any two iterations are nearly equal. So this is the Gauss-Seidel iteration method for two variables. 3 variables and 2 variables. Only one example is there. Next, Jacobi iteration method. So Jacobi iteration method. So Jacobi iteration method is also same. So 2 variables, x1. So kth iteration is equals to f1 of k minus 1th iteration. X power k minus 1 comma y power k minus 1. So yk. Kth iteration is equals to f2 of x power k minus 1 iteration comma y power k minus 1 iteration. So like previous iteration values. Next, system of 3 variables. Jacobi iteration method, system of 3 variables, the same. Xk is equals to f1 of x power k minus 1 comma y power k minus 1 comma z power k minus 1. So y power kth iteration is equals to f2 x power k minus 1 y power k minus 1 z power k minus 1. Next, z power k is equals to f3 x power k minus 1 y power k minus 1 z power k minus 1, where k is equals to 1, 2, 3. So these are the kth iteration values of 3 variables. Here only 2 variables, x comma y. Here 3 variables of Jacobi iteration method. So consider the same example. So pi psi. Pi is equals to x plus 3 log base 10 x minus y square is equals to 0. So pi of x comma y is equals to 2x square minus xy minus 5x plus 1 is equals to 0. So Jacobi iteration method, here also same, x naught, y naught. X naught is equals to 3.4, y naught is equals to 2.2. So we can write x value. X is equals to x minus 5, x into y plus 5 minus 1 by 2. So y is equals to root x plus 3 log x. In this equation, so we can write x value. In this equation, we can write y value. Or in first equation, we can write x. In second equation, we can write y value. So first iteration of x. First iteration of x. So substitute x is equals to x naught, y is equals to y naught. So that is x1 is equals to root x naught into y naught plus 1 minus 1 by 2. So this is x1 in first iteration. So y1. So y1, so substitute x is equals to x naught. Here, x naught plus 3 log x naught. So this is y1. So next, second iteration. The second iteration, so we are using first iteration values. X2 is equals to root x1 into y1 plus 5 minus 1 by 2. So this is x2 in first iteration. So next, y2 in second iteration. So root x1 plus 3 log x1 is equals to 2.263. So each and every step we can compare. So first time, second time, so these are the first iteration values. So these are the second iteration values. So compare, at least 3 digits are nearly equal, or we can proceed next iteration. So next here, third iteration, fourth iteration, fifth, sixth, seventh, eighth, ninth. So 8th and 9th iterations are nearly equal. So continue this process up to 9 iterations. So this is 9th iteration, 8th iteration values. So these are the 9th iteration values. So these two are nearly equal. So these are taken as solution for the given system of non-homogeneous equations. So this is the Jacobian iteration method. Newton-Raphson method, Gauss-Seidel, and Jacobi iteration method in system of nonlinear homogeneous equations. Seven 7.6 is no need up to this example only. Example 4, up to example 4 only. Any doubts? In next class, eigenvalues and eigenvectors also
Sir,
in Tumana class. చెప్పండి
ఫస్ట్
చెప్పండి.
దాంట్లో ఎక్స్ నాట్ వై నాట్ వాల్యూస్ రాశారు కదా సార్, అవి ఎలా రాశారు సార్?
అది ఇంటర్సెక్షన్ టూ లైన్స్ ఇచ్చాడు కదా, ఈ లైన్స్ ఇంటర్సెక్షన్ అది ఇక్కడ డైరెక్ట్ ఎక్స్ నాట్ వై నాట్ 0 0 తీసుకోవచ్చు. 0 0 తీసుకున్నా మీకు ఇటరేషన్స్ ఎక్కువ వస్తాయి. ఇక్కడ 3.4 2.2 తీసుకున్నారు కదా, ఇవి ఎలా వచ్చాయని అడుగుతున్నారు కదా.
అవును సార్.
ఈ వాల్యూస్ డైరెక్ట్ గుర్తుపెట్టి ఇక్కడ ఉన్నాయి ఓన్లీ 3 ఎగ్జాంపుల్స్ ఉన్నాయి, 2 ఎగ్జాంపుల్స్ ఉన్నాయి మాకు. ఈ 2 వాల్యూస్ గుర్తుపెట్టుకున్నా పర్లేదు. లేకుంటే ఏంటంటే 0 నుంచి తీసుకోండి, 0 0 తీసుకొని చేస్తే మీకు ఇటరేషన్స్ ఎక్కువ వస్తాయి. ఇప్పుడు ఈ వాల్యూస్ తీసుకుంటే మీకు ఓన్లీ 3 ఇటరేషన్స్ లో ఆన్సర్ వస్తే, మీకు 0 0 తీసుకుంటే 6 ఇటరేషన్స్ లో ఆన్సర్ వస్తుంది. ఇటరేషన్స్ ఇంక్రీజ్ అవుతాయి. సో మీరు డైరెక్ట్ గుర్తుపెట్టుకుని ఇక్కడ ఏమంటున్నాడు, ఇనిషియల్ అప్రాక్సిమేషన్ ఇండికేట్స్ ద ఇంటర్సెక్షన్ ఆఫ్ గ్రాఫ్స్ అంటున్నాడు. అంటే మీరు గ్రాఫ్స్ డ్రా చేసి ఇంటర్సెక్షన్ వాల్యూస్ ఫైండ్ అవుట్ చేయాలి, అప్పుడు వస్తుంది. సో కానీ డైరెక్ట్ మీకు క్యాల్సీ ఉంటుంది, సైంటిఫిక్ క్యాల్సీ ఉంటుంది. ఆ సైంటిఫిక్ క్యాల్సీ లో డైరెక్ట్ ఈ వాల్యూస్ ఎంటర్ చేస్తే, ఈ 2 వాల్యూస్ ఎంటర్ చేస్తే మీకు డైరెక్ట్ ఆన్సర్ వస్తుంది. ఈ 0th ఇటరేషన్ వాల్యూ చూపెడతాయి, సొల్యూషన్ చూపెడుతుంది. సైంటిఫిక్ క్యాల్సీ అని ఉంటుంది. ఆ క్యాల్సీలో ఈ 2 ఈక్వేషన్స్ ఎంటర్ చేస్తే మీకు 3.4 2.4 డైరెక్ట్ చూపెడుతుంది. మీరు ఎగ్జామ్ లో సైంటిఫిక్ క్యాల్సీ తీసుకెళ్ళొచ్చు, అలా ఉంది ఎగ్జామ్ కి. న్యూమరికల్ మెథడ్స్ కి, మెథడ్స్ ఆఫ్ అప్లైడ్ మ్యాథమెటిక్స్, ఈ 2 ఎగ్జామ్స్ కి సైంటిఫిక్ క్యాల్సీ అలా ఉంది. డైరెక్ట్ క్యాల్సీ లో టైప్ చేస్తే మీకు ఈ వాల్యూస్ వస్తాయి. 3.4 2.2 వస్తుంది మీకు డైరెక్ట్లీ. So we will continue on tomorrow, eigenvalues and eigenvectors.